Well, hello everybody, Dave here, and we are going to continue our lessons on set theory with dealing specifically with intersections and unions of two sets. So the first thing we need to recognize is how important it is to understand the shaded region on a Venn diagram and how to represent that with notation. You'll see the top two sets there, we have a circle completely filled in. Well, that represents set A and B. You'll notice that that includes the overlapped region because, again, even though there are some people in set A that also do B, all of the people that are represented by set A are represented by that shaded circle. The next two now are the complement of those sets, so not A, that's what the apostrophe means, and not B. And so if A was the shaded region, the entire circle of A, then not A is everything else, including the shading of the parts of B. The same thing holds true with not B. You can see that only the circle B is not shaded, but the rest is. If you look at the next one, you see that we have everything shaded in the circles, including the overlap, and we have the notation underneath that has that U. Remember that that means union, which represents A or B. So when you're asked to do a question where you're supposed to find A or B, this is the area that you're supposed to find. Again, if we're finding the complement of that, not A or B, that's the shaded region on the outside of those circles. The final one we want to look at is the overlap in the middle, which represents A and B. If you can see the notations there, you can see that it's this upside down U, which represents the intersection. If we do the complement of that, the not A and B, well, what we get is everything shaded except for that overlap. And finally, just to be clear, if you do want to shade in that region of just A, not including B, you'll see that we have this slash in between A and B. Well, that represents A, not B, and the second one represents B, not A. And in this case, you can see that it has the shaded region of A and B, but it now doesn't include that overlap because we don't want to include anybody in A that also participates in B, and the same with the last set. So let's do a question that involves using these notations. We have a deck of cards, and we want to create a set based upon these deck of cards, and they're specifically asking to create sets for the entire deck and then each of the suits. So it's important to remember a couple of things about a deck of cards. The first is that there are 52 cards in the deck, and that there are 4 suits. Each of them have 13 cards. So if we take a look at the way that we're going to create the sets, we're going to call the universal set U the entire deck of cards. Well, the notation on the right there is the number of elements in U, which is just count up the number of cards. Well, as I said, there are 52 cards in the deck. So it's important to see the difference between the two. Without the N in front of the U, we're just looking for the set itself. But when we're looking for the number of elements in that set, that's just a number. And so you can see for the 4 suits, we've done exactly the same thing. Now, you could totally list off each of the cards, the ace of spades, the 2 of spades, and so on and so forth. But again, when you're just establishing what a set is, you don't necessarily need to list them all off. If you're doing a numerical problem that has maybe a set of 10 numbers, you may want to consider breaking those up to actually physically show what the numbers are. So again, we know that there's 13 cards per suit, so each of those sets has a number of elements equal to 13. It is important to note that because U is the universal set, if we take the sum of the 4 numbers associated with each of the suits, we should end up with our original number of 52 cards. So now let's go ahead and describe the union of the set of cards that are spades and cards that are hearts. So we have to remember that when we're talking about the union, the notation that you see there is with the regular side up U, which means or. So when we're talking about S or H, we are referring to the set of the 13 spades and 13 hearts. So when we have to count the number that are either spades or hearts, in this case we simply add up the number of spades and the number of hearts. However, if we had to describe the intersection of these two sets, the intersection again means and so the number of cards that are spades and hearts, Well, we know from experience that there are no spades that are also hearts, and so the answer to this is 0. Now the notation that you see there with the two squiggly brackets with nothing in between, or this 0 with a line through it, means the empty set or the null set, and either of those notations is appropriate when it comes to this particular intersection. So if we go even further now and try to describe this in terms of being mutually exclusive or disjoint, we have to go back to our understanding of previous lessons. And you'll remember that with mutual exclusiveness, we are referring to sets that have no overlap or have no values that occur at the same time. And so because there are no spades that are also hearts, they are by definition mutually exclusive. And if we took a look at a Venn diagram that represented this, we would see two circles that are not overlapped. And so to be mutually exclusive and disjoint means that there is no overlap in the Venn diagram. So finally, let's describe the complement of the set of spades or hearts. Well, since we're referring to not spades or hearts, we are implying that we are dealing with the set that are clubs or diamonds. And so the notation that you see down there is showing you that we have the set of spades or hearts. We are taking the complement of that, the not version of that, and by definition and by the question itself, that's referring to the set of clubs or diamonds. So we can summarize this mathematics with an equation if we include the principle of inclusion and exclusion. So if we take any two sets and overlap them such that there are quantities in which are in A and B, we can come up with the mathematical value for the number of elements in A or B if we take the sum of the two sets and subtract the number of elements that are in both A and B. And so that sounds a little confusing, but if you take a look at the diagram on the right there, you can see that what we've done is we've pulled apart the circles that were overlapped. And if all we did was add up the number of elements in set A and the number of elements in set B, you'll notice that we have double counted the overlap for A and B. So what this subtraction is doing is actually subtracting one of those double counts so that all we're left with is the total number of elements in A or B. If you take a look at the two sets at the bottom there, if we know that the sets are disjoint, that means that they have no common element, which means the number of elements in A and B is equal to 0, which means that our equation above actually simplifies down to the number of elements in A or B is equal to the sum of the two sets. So it's really important for you to understand when you use the first equation and when you use the second equation. The fact of the matter is the second equation is the first equation, just with an understanding that there is no overlap between the two sets. So I encourage you strongly to understand the first equation and how it applies to the second. A common mistake made by students is to immediately use the second equation whether they understand it or not. So let's do an example that applies this equation. Jamal has surveyed 34 people at his gym, and he learned that 16 people do weights 3 times a week, 21 people do cardio 3 times a week, and 6 people train fewer than 3 times a week, and we're trying to understand how Jamal can interpret his results. So it's clear that we're basing our results on this 3 times a week idea. So I'm going to set up my sets to approach this idea. I'm going to let G be all the people that were surveyed, W be all the people that do weights 3 times a week, and C be all the people that do cardio 3 times a week. The first thing to do to approach a question like this is to create a Venn diagram and fill out what you know. Well, in this case, we don't know a lot, but we do know that 6 people train fewer than 3 times a week. We'll remember from our shaded regions that that means the outside parts from the circle have to represent that 6. From there, we have to understand how many people are inside the circles. Well, we know that there are 34 people total that have been surveyed, and 6 people don't do weights or cardio 3 times a week. So if we subtract this 6 from 34, then we know that 28 people represent the number of people that either do weights or do cardio. Well, this is an important quantity to have because now we can actually find the number of people that do both weights and cardio. And the reason we're going to take this approach is because we can assume that there is an overlap between the two sets, that there are probably people that do both weights and cardio 3 times a week. And so that means that these are not mutually exclusive, which means we can't just simply add up the sets. So we go to our general equation for the number of elements in W or C. And you'll notice that we actually have all of the numbers available if we solve this equation for the number of elements in W and C. And so that's what the second line there is. And you can see that we're going to take the sum of the two sets W and C and then subtract the number of elements that are in W or C, which is the value that we calculated before. And the nice part about this is when you perform this calculation, what you end up with is the number 9. And that 9 represents the number of people that do both cardio and weights in a given week. Well, based upon that 9, we can fill out the other two sections. Because you'll remember that the crescent moon section on W there represents the people that do weights only. Well, if we know that 16 people do weights and 9 of those people do weights and cardio, then we know that 16 minus 9, or 7 people, just do weights only. If you take a look at cardio, if we know that 21 people do cardio 3 times a week, but 9 of them do both cardio and weights, 21 subtract 9 tells us that 12 people do cardio only. So this entire Venn diagram represents the results that Jamal has. So our interpretation is what you see before you. Now it's important to recognize as well that if we take the sum of all the numbers present, 7 plus 9 plus 12 plus 6, well, that's going to be 34, which makes sense because, again, the rectangle of a Venn diagram is meant to represent the universal set. So if you have a number that isn't 34, you've made an arithmetic error somewhere. So everybody, that's it for this lesson. I've given you the notations and I've associated those with the Venn diagrams. Now it's up to you to understand the process by which you have to make these solutions, and be sure to represent everything as best you can with this new set notation. Best of luck to you with your practice problems, and we'll see you again.